Okay, hi. Welcome to the third video on a word problem on quadratic functions. So I want you guys to pause the video now and try to understand what the question is asking us to do. Okay? Okay, welcome back. I hope you have went over the questions and understand the context and what they want us to find. So we have Louisa. Louisa is going up. He's biking up a mountain and then biking up and then coming back down. The average speed is 35 km per hour, faster than. That's the average speed going down is 35 km per hour, faster than the speed going up. Because coming down is faster, 35 km faster than going up. Now, if the distance from the bottom to the top is 40 kilometers, the distance from the bottom to the top is 40 kilometers, then they want us to find the average uphill and downhill speed. That's a tough one, right? So this is we have been dealing with speed and distance and time for a long time, right? Since middle school. So speed is equal to distance over time, right? Over time. So in this case, they want us to find the average uphill and downhill speed. Okay, so we are going to use this to help us out. Now, they already told us the information that we have is 3 hours. This 3 hours is time, right? So maybe it would be helpful for me to express what I have here for time. So my time would be equal to the distance over speed, right? Okay, so maybe I'm going to use that later as well. So I'm just going to keep those two notes on the side, and we'll refer back to that later on. Okay. Now, it says that Lucia goes up and come back down. Let's say this is the top. So put a flag there. That's the top, and the time for that whole trip. The time is, it says 3 hours to ride up and back down. So the time is 3 hours. So, which means going up does the time going up equal to half of 3 hours? Does that make sense? Of course, when we go up, it's going to be a bit slower. So the time going up will be will take longer than the time coming down, right? So I'm going to say time. I'm going to put down this t up. So that means time going up plus the time coming down, t down, is equal to 3. Right. So how do I find the time going up? My time, so I'm going to come back to this. Right. The time is equal to distance over speed. Right. So I don't have my distance. Yes, I do. Right. It says that the distance. Where is it? The distance from the top to the top. So one way from here. Oh, where's my cursor? So from here, from the bottom, all the way up to the top, that is 40. Right? This is 40. So likewise, from the top to the bottom would also be 40. Right? Assuming that this is a perfectly symmetrical mountain. Okay. So 40 going up, 40 coming down. So my t up now becomes, the t up is just equal to the distance which is 40, divided by the speed going up. We don't know what the speed going up is, so let's say I'm just going to put that as x. Okay, so this is x. I'm going to put down x up. Speed going up. Now my t down is equal to same thing. The distance is still 40, but by the speed coming down. Right. Okay. Now, if I look at this, the average speed riding down is 35 kilometers per hour faster than the speed going up. So, which means my x down. So that sentence right there gives me the relationship of my the relationship between my x down the speed coming down is 35 kilometers per hour faster than the speed going up. Hey, what's wrong with my pencil? Than the speed going up. Right? Which means I can now, for this x down, I can write that in terms of 35 plus x up, right? So, and then I can combine them later, correct? So this part, my t coming down is equal to 40 over 35 plus x up. Remember that my x up just represent the speed going up, right? So now I can put this, combine the t up, combine my t up over here with my t down over here, and make that complete this equation. So I will have 40 over x up. That's my time going up, plus the 40 over 35 plus x up. This will be the time coming down, the speed coming down, sorry. This whole thing is the time coming down, which is equal to 3. Right. So now I only have one variable, which is x up, and I can find that. Right. In fact, I can go ahead and put this in my equation now, in my calculator, if I want to. Let me just simplify this a little bit further. So I want to move everything to the left hand side. I will have 40 over x up plus 40 over 35 plus x up minus 3 is equal to 0. So if I put this in my graphing calculator, I just have to find my zeros, okay? And I'm just going to do that. So let me open up my graphing calculator. Okay, so here is my graphing calculator, and I'm just going to clear everything and put the equations in. So fractions, right? We're going to start by typing fractions. So I'm going to go alpha y equals 2, and that will bring me the fraction manual. Click on the first one, and I'll have 40 over x plus another fraction, 40 over x plus 35, or 35 plus x, doesn't matter, and minus 3, and that's it, right? And I will be looking for my zeros. And my graph is not zoomed in correctly, so I will have to adjust the zoom later on. I'm going to zoom standard. I need to go to the right a little bit more, so I'm going to go zoom out a bit further. I'm going to zoom out towards the right. Okay, so here I have a 0. That's where I have a 0. I'm going to go second calc, go to my 0. left bound somewhere there, right bound somewhere all the way to the right. That's good. And a guess value can be anything. And my 0 happens when x is equal to 17.8. Alright, 17.8. So my x up is equal to 17.8. So my uphill speed is 17.8. Then my x down, my downhill speed is just 17.8 plus 35, right? Plus 35. Which gives us, how much is that? Something 0.8. That's 52.8. 52.8. Okay? I hope this was helpful, and I'll see you guys in class.